Okay, let's see another example here. What if we had the following code? We had an int pointer, we'll call it dyneInt for dynamic int. And then here's what let me draw some pictures a little bit different than what we've done before to try and illustrate what is going on. So here in step one here, we're saying that we are declaring a dyneInt, and that is on the stack. And then what it does is it just exists. Now with 2, what we're going to have here with 2 is that it is making this memory location. I guess in all fairness we'd delete that. It makes that memory location, and then it assigns a pointer to it. Okay, so we'll just do this graphically by drawing an arrow over to that memory location. Now it doesn't set the contents here of that memory location. So in step 3 there, we dereference this, and I haven't indicated the address here, I've shown it with an arrow. We're going to say that the contents are 42 here, and that's step 3. And then step 4, here we have delete, and what delete does is it says that this address is available. So it's a little hard to show it graphically here, but somebody else can pick it up. But notice I didn't change the contents here, and I did not change this arrow here. Delete does not do that. Okay, so sorry, it went off the screen. So delete just frees up the memory. It doesn't change the value of the pointer, and it doesn't change the value of the memory address that's being pointed to. Okay, so what do we need to do to fix that? We need dyneInt equals null. We'll call this the 5th step. Okay, setting it to null now deletes that. Notice it didn't change this value, but the system says, hey, this is a garbage value. You can use it for whatever you want. But so setting it to null now sets that equal to 0, illustrated with no pointer. Okay, so every time you delete, then just set it to null. It's worth the extra characters that you'll type. Let's look at the dynamic array example. This code is available online. Dynamic array. Let's get the right one here. Paste over that. Let's look at this code. Okay, we have some includes, we have main, we have a count, we have an initialize. Generally should initialize. And we have a pointer here, rand array, and we have a prompt. Good thing we have a prompt. And we're going to read in how many random numbers we would like. Now we're going to allocate that memory, the count number. Okay, new does 3 things. It allocates memory on the heap. In this case, it's going to allocate count number of ints. It's going to return a pointer to that first memory location. So this had better be a pointer, and it is good. And then it'll call the constructor if it's an object. Oh, it's an int, so there's no constructor. Okay. And then every time you do new, you should test it to make sure that it's not equal to null. If it is, we have an error. It wasn't able to allocate the memory. Return 1, exit. You need to do something. You may have never seen this before, but if you're doing random numbers, you need to initialize the random seed. Random numbers aren't really random. It's a sequence of numbers. And what seeding it does is it says start here in all these random numbers and then go through the list. The list is really long, and so it really feels like a random number. So we're just going to loop through. We've allocated count amount of space for each number, and so we're going to just get a number between 0 and 99, and assign it into that array. Okay, so we can treat a ran array. It's a pointer to count number of ints, and so we can use that as an array. Then we're just going to print them out. And of course, with every new, we have a delete, so we clean up memory. Okay, let's see that. How many random numbers do you want? I'll go with that. Great. Let's 11. Oh, I didn't get my number. Okay, random numbers. Looks random to me. Okay. So here's a good example of a dynamic array. We have, so let's talk about the syntax. Syntax for a dynamic array. We have data, oh, we're about off the screen, sorry. Data type pointer, and then array name, and then we can do equals new data type int expression, and that will give us an int expression number of data types and allocate it on the heap and then assign it to int array. So, and a concrete example of that would be, for example, array equals new int count, as we just saw. Now, what if we wanted more? Need more? Well, we could just call new again. And let's double the number of ints that we want. And so then that'll write over the memory location where array is pointing to. It'll point to our new array that has twice as many elements. Okay? For a two-dimensional array, let's look at an example of that. Okay, two-dimensional array. And as you saw, the code is available. So we need to keep track of rows and columns. And notice what we're doing here. We're doing an int pointer pointer. This is what a two-dimensional array looks like. It's a pointer to a pointer. You can think of these as arrays, one array pointing to another array. So we need to ask how many rows do you want and how many columns do you want. So what we first do is then we allocate the number of rows. Notice when we do new, we said we want int pointers. We need rows numbers, a row amount of int pointers. Okay, and then we're going to return it to that. We're going to return a pointer. Is this a pointer? Well, yes, it's a pointer to an int pointer. So, okay, we can assign it to there. Now to allocate the columns, notice we need to use a loop. Because for each one of those rows, we need to allocate memory for the column. So that means that this memory is contiguous. The pointers for the rows are contiguous. And each set of columns with a row is contiguous. But one set of columns for one row is not necessarily contiguous, meaning right next to the memory for the other rows. Of course, whenever you call new, we need to test the allocation. Really, I guess this should have been up here, but it made it a little cleaner. Again, we need to initialize the seed, but now notice we have a double for loop. We need to go for every column, for every row, and then assign our numbers from 0 to 99. Of course, then to print it out, we need a double for loop to iterate through for each column, for each row. We're going to print out a value and then make sure we get the new line at the right place and then one at the end. Remember what I said about for every new, you need to delete? Well, notice the order which we have new and delete here. We have a new for the rows, and then we have a new for the delete. And notice, I didn't point this out before, but notice this is where the values are going to be stored. It's just an int. It's not an int pointer. We're making this many ints. And notice we're assigning it to an array. And so because it's a pointer, this is a pointer to the columns. So we had a new array notation here, and then in a loop we called new array notation. So what we could expect to see for delete to clean up the memory is a delete array notation in a loop, and then delete array notation singular. And yes, you need to do it in the loop and then the singular one, the columns and then the rows. Okay, let's see it. The build. Yay, it built. Okay. Why don't we say 5 and 6? Okay, so here's our random numbers. We have a new line at the end of each row. So 1, 2, 3, 4, 5 rows. Good. And 1, 2, 3, 4, 5, 6 columns. Yep, it all matches up. If that didn't make sense, rewind and watch again. Okay, so what would that look like if we were to plot, kind of draw it with my little ASCII art version here. So we have this dynamic 2D array example. And so this would be rand array here. It's a pointer. It's a pointer to an array of it's a pointer to an array of integer pointers. So then when we allocated this is a little ASCII art pointer. Okay, so this memory location, I just drew arrows because it's something, but the actual values don't really concern us here. And so, but it is a pointer, and that's different than just an integer. It points to an array, and we consider that array rows, and that's here. I can't. Well, I can highlight. No, I can't highlight rectangular. Sorry. And then in a for loop, we said allocate this memory, this many columns, 6 columns. Oh, that's 5 columns. And then we said, next iteration through the for loop, we said allocate this memory, allocate this memory. Now the way it's drawn, it looks like it's all nice and neat in memory, but it might be all over the place. We have no guarantees. But it doesn't matter. The address is here, and when we dereference it, it works out. So is this a 5-row by 6-column 2D array, or is it a 6-row 5-column 2D array? Might blow your mind a little bit. It doesn't necessarily matter if we're careful, but the convention is we do rows first. So in this case, it'd be 6 rows by 5 columns. Okay. Last topic for today, for this video, memory leaks. You may have heard of them. Hopefully you have. So what is a memory leak? When a variable has been allocated, but it has no pointers to it. When I think we could clean this up, a memory location has been allocated, but it has no pointers to it. So above we said, hey, we need more space. Need more? Then what did we do? We just overwrote this. Well, what about the memory contents that were allocated here? We no longer have a pointer to them. So what we should have done is do something like this, where we have an old array equals array. We copy the address of this memory location on the heap, and we stored it in old array before we overwrote it. And that's if we wanted to do anything with it. If we didn't, we should just clean it up with delete. There's a memory leak in the pointer video. Yes, I knew about it when I made it. See if you can find that one. Signing off.